Okay, so for today, I will continue with the problem example on the trust, as well as the preparation for the exam. Okay, as I told you before, next week on, we are not so sure about the day yet, but next week they will we will help the exam, the first exam for statics. Okay, and just wait for the announcement. I will announce it via our EduNext. Okay, and it will be next week. So try to prepare yourself for the exam. Okay, and as I told you yesterday as well, the exam will cover everything from the beginning until trust. Okay. So for today, I will continue with the, our discussion on the trust. Okay. So this is one of the problem which has been which used in the previous exam. Okay, previous exam problem. As you can see, it's a trust problem. Okay, I want you guys to try to read it carefully before we try to solve it together. Okay. So here, the main question is the force in the member Fi and Cj. Okay, Fi and Cj. So this one and this one. Okay, I want your opinion on this particular problem. Okay, should we use the section method or should we use the join method? And do we need to solve for the external forces or not? Anyone have any idea here about this one? Only two members that we need to solve here. Only this one, Fi and Cg, this one. Irsyad Nabil, what do you think, Irsyad?
So I think section should be fine.
Section should be fine, okay. But can we do the section? Can we do one section to solve for both problem or not? Or we just need one by one? Irsyad.
What, sir?
Do we need to? Can we do a section, one section to solve for both problem, or we need to do a two separate section to solve for the problem?
I think two.
Yeah. Yes, it is correct. Okay, we cannot solve this just using one section because it's quite impossible. Remember that one section can only solve for 3 members only. Yeah. So Nabil, again, for the first problem, Fi, which section that we're supposed to cut? Which part of the section? Which part of the member that we're supposed to cut? Which member that we're supposed to cut?
Can we cut it vertically? So Fi.
So you mean like this?
Yes.
Okay. So by doing so, we will cut df, fi, and hi. But the one that we need to solve is only fi, right? Okay. So the free body diagram will consist of this triangle FHG. So it will be like this. Okay. And what forces there is there? Irshad?
Fi to the bottom left.
Fi, yes, to the bottom left. Just always assume it as tension when we don't know the value.
Minus
Fi,
Fi
and FHI horizontal to the
yes.
left, right?
Yeah.
Or to the right?
Tension.
Tension. Left.
And FD.
HI.
FFD.
FFD to the top left
Top
or
left.
bottom right? Top left. What else do we have there?
3000 Newton and 1000 Newton at H and G.
3000 Newton, 1000 Newton. And remember here, FFD and FHI, we do not need to solve it. But if like it or not, we have to solve it. Yes, yeah. In that case, we have to solve it. But which one that we're supposed to use first from our three equation?
Can we use the sigma moment first?
Okay, sigma moment in
point F.
Point F. Okay. Sigma moment point F. So we will solve FHI, right? In that case. Okay. Yeah. Would you mind to solve it for me? What we have there?
I think it's 1000 times 2.
1000 times 2, okay. 1000 times 2. What else? 3000. Will there any moment due to 3000?
No, I don't think so.
That's correct. What else?
And then FFI sine something.
I or of FHI. This one is the center of rotation, remember?
Yeah. All right. Yeah, FHI sine.
Sine? You need to use sine here.
Wait. Oh no. We can use FHI without the sine.
Plus or minus?
Wait.
But here just now you use clockwise, positive.
Oh, it's also positive.
Positive. FHI multiply by, what is the distance there?
Wait. Is it 1.5?
Yep, correct. It's supposed to be 1.5 because this one is the same with this one. So because this one is the same with this one as well. So this one will be the same with that one. So it will be, it will be half of that, this one. Okay, this will be half of this. So it's 1.5 equal to 0. So FHI will be
negative
2000
divided by 1.5 tunggu sir. I forgot how to do basic math. 1333.33 repeating.
Wait a minute. 1000 divided by 1.5. Okay. 1 Newton. Okay, 1333.33 Newton. Okay. We got FHI. Now we want to solve for fi, right? But is there any way to solve that without? Okay. No. So which one next step we supposed to use then?
We could use sigma fx maybe. Oh well, no, that would need FD2, yeah.
Yeah. No, there is no way to avoid FFD. So you can use sigma fx. You can use sigma fy as well.
Oh, okay. Let's maybe do one of them first. Fx
Yeah.
first.
Sigma fx. What you have there?
Huh?
What you have for the
Oh,
sigma fx?
we have negative. Wait. We have 1,300.
Oh, sorry. This one is
33.
negative. Okay. Yeah.
Yeah. Oh, okay. Then negative 1,333.
Okay. 1,000. Okay. What else?
We have. I think sine FFI.
Okay. Plus fi. That one is supposed to be sine. Oh,
Yes.
this one. Okay. You mean the angle is this one, right?
Yes.
Okay. What is the angle? What is the angle there?
Oh wait, if that's the angle.
Sine.
Yeah, that's sine. Tunggu sir. That's 2.5. That's 4.
1.52. So actually the triangle is supposed to be like this, right?
2.5.
1.52. And what is
2.5.
here?
2.5, sir.
2.5. So the sine is supposed to be 2 over 2.5, right?
Yes.
0.8. Okay, so FFI multiplied by
2 over 2.5.
0.8. Yeah, 0.8, right?
All right, yes.
And what else?
And we get
Plus.
Plus FFD.
Multiply the same, right? 0.8.
Yeah.
Equal to 0. Okay, that's the first equation. Now the second equation, using sigma fy equal to 0.
Negative 1,000 minus 3,000.
Negative 3,000, negative 1,000. What else?
Cos FFI.
Okay,
So that would be
negative as well.
1.5. Oh yeah.
Because it's going down as well. Negative.
Yes.
FFI 1.5 divided by 2.5.
Yes.
So it's 0.6 plus FFD multiplied by 0.6 equal to 0.
Yes.
Okay, now try to solve FFI there.
Like isolate FFI?
No, try to solve for FFI. Okay. One of the way to I will tell you on how to do the substitution and elimination easily. Okay. One of the way is we can solve for FFI by substituting FFD like this. Okay, by substituting FFD with only FFI variables. So what you can do is from one of the equation,
solve for FFD.
Yeah, solve for FFD. FFD here is equal to 1,000. Yeah, this one. Okay.
Minus 0.8 FFI.
yeah, minus 0.8 FFI and divided by 0.8.
Yes.
Okay. So after that, you can substitute this value to this one in order to solve for FFI. Okay. So divided by 0.8. Okay. So this one is supposed to be FFD is equal to 1666.66 minus FFI. So this is the one that I will substitute to this one. So later what we will have will be minus 4,000 minus 0.6 FFI plus FFD 0.6 multiplied by FFD. FFD there, I can replace it with this one. So 1666.66 minus FFI, then equal to 0. Okay, from there, what we will have is minus 4,000. Okay, still minus 0.6 FFI. Okay, plus, what is that?
Oh,
1,000. So this one is plus 1,000. Okay, minus 0.6 FFI equals.
yes.
So what we will have there is 1.2 FFI equal to minus 3,000, right? So what we will have is 1.2 FFI equal to minus 3,000. Okay, so what we have is FFI is equal to
2,500 negative.
3,500. Okay, negative 3,500. Eight, 2,500 you mean?
Yes,
Oh,
I said that.
okay, so this one is 2,500 Newton. FFI is 2,500, so we can solve FFI using that way. Okay, thank
Do
you.
we still have to solve for FD, or can we just skip it now?
Yeah, you can just skip it because we don't have to solve for that. So FFI only that we need to solve here. Then, in order to solve for CJ, what we supposed to do, Nabil?
We section again.
Section again, but the problem here,
there is no forces.
In this case, we don't know yet about this particular force and the force shear, right?
Oh yeah, I didn't even see ED.
Yeah, so for that particular problem, we have to solve for ED, either ED or AX, AY. So
without sectioning first.
We don't do the section first, but we solve for the external force first. Because if we do the section without solving that, we will not be able to solve for AD. Okay, so we try to solve for the external force first in order for us to solve for this one. Okay. This one is FED. Okay. And AXAY. Okay, 3,000, 1,000. Okay. So this is all the external forces which is happening to the truss. Remember here, FDE, I replace DE here as the external force because it's two force member. So in order for me to make it easier, I will replace this as external force like this, which has this, the same direction as the member. Because by doing so, the external force, the unknown external force that we have is only 3. Yeah. Okay. The unknown external force that we have is only 3. Only FED, AX, AY. Okay. If you have an external member like this, okay, try not to solve it as still the member there, and we have EX, EY like that. Because by doing so, you will add unnecessary unknown external force. This one is better for us to just remove this particular member and replace it with the force which has the same direction as the member, like this. Okay. In order to do the section here, we either solve for the top part or the bottom part. So in this case, we either need to solve for FED or AX, AY, like that. So we can solve only this or this one. Okay. Which one do you think that is the best for us, Irshad?
I think solving FDE is easier.
Yep, correct.
For now.
Solving FDE is easier because we can just solve this using sigma moment at A like that, right?
Yes.
Okay. Using sigma moment at A, we can solve for FDE. So in that case, I will make it fast. So if clockwise is positive, what we will have is 3,000 multiplied by 4 meter plus 1,000 multiplied by 6. Okay, minus FDE multiplied by what? Is that 9?
9.
Okay, 9 meters equal to 0. Okay, by doing so, we will be able to find for FDE. 6,000, 12,000, 18,000 divided by 9. 2,000, okay? So FDE is 2,000 Newton. After we know the value of FDE, now we can do the cutting. where we supposed to cut it, Irshad?
Between C and B horizontally.
Okay, like this, right?
Yeah.
Okay, so after that, the one that we will try to handle is this
The
particular
clubhouse.
triangle, right? You mean?
Yes.
Okay, so let's try to draw the free body diagram. So it will be like this. Oh. Okay, it will be like that. That we will have 1,000 here. We will have another 1,000, 3,000 here. Then we have BC, CJ, and IG. FBC, it's like this. All tension, okay. CJ. And then FIJ. And we have FDE as well. But we know the value already, so we will just put 2,000 Newton here because we know the value of FDE there. This is it, right, Irshad?
Yes.
And the one that is in question is
CJ.
CJ. CJ is this one. Okay. We do not need to solve for the other. Okay, we do not need to solve for FBC and FIG. So in order to solve for CJ, which equation that we're supposed to use? Remember, we have three, okay? Sigma Fx equal to 0, sigma Fy equal to 0, and sigma moment equal to 0. Which one that we can use to solve for CJ?
FX, because
Yep,
it's
correct.
only CJ and 2,000.
Yep, correct. So we can just use sigma Fx equal to 0 in order to solve for this. Because only CJ, they have a X component in comparison to FBC and FIG. FIJ both only have a vertical component, so we can just use sigma Fx. So in this case, if going to the left is positive, what we will have is 2,000, right? 2,000 Newton minus FCJ
and
FCJ, okay, and it's supposed to be
cos.
Yeah, if this one is alpha, cos alpha equal to 0. Alpha there is supposed to be what? Cos alpha is supposed to be 3, 2. Okay, this one is slightly different.
Square root of 13, I think, sir.
Okay, let us draw it first. So the triangle is supposed to be like this. This one is 3, this one is 2, right? This one is supposed to be 9 plus 4. Yeah, correct. Square root of 13. So if we want to find out the cos the cos alpha. No, this one is sin, okay?
Sin?
Yeah, this one is sin alpha, right? If this one
right.
is alpha, that one is sin alpha.
2 over square root of 13.
Yeah, so it's supposed to be 2 over square root of 13. So 2,000 Newton minus FCJ multiplied by 2 over square root of 13 equal to 0. Okay, so we will know the value of FCJ then. There. FCJ is equal to 2,000 multiply by square root of 13 divided by 2. Okay.
Yes. 3605.55.
Yes, correct. It's supposed to be equal to 3605.55 Newton.
Yeah.
Okay, so that is the value of FCG, and this one means don't forget to give the information here because
Tension of
it's
the
part of the question. Okay, so
yes.
FCJ is tension. Okay, and just know FFI. Where is FFI? FFI is negative, so it means that if FFI is under compression. Okay, thank you very much, Iso. So
Yes,
this is the problem example from 2 years ago. It's not that hard, but you have to know where to do the section, and in order to solve for the unknowns, what we're supposed to do, you have to know about that. So, okay. Actually, in order to prepare yourself, in order to prepare you from the previous exam, I already try to take a look at the previous exam. Okay, so you can see here, this is the exam six years ago. Okay, I've been in the ITV from 2014, so it's been 8 years. Okay, so it's 6 years ago, and the first problem here is a trust problem, and as you can see, this trust problem is actually statically indeterminate problem. Okay, statically indeterminate problem. And after that, you have to solve for this one is an equilibrium problem. So, okay. Some of the problem for the exam preparation here, I will put it as part of your homework. So this one will be part of your homework. Okay. And I believe for this one, for the mobile crane here, in the equilibrium, I believe we have discussed about this as well, how to prevent it from tilting. What is the maximum force that it can hold which almost make it tilt like that, which almost make it roll over like that. I believe we have discussed about this. Okay. And this is from 5 years ago. Okay. And maybe this one I will put it as our homework as well. Okay, for the thrust problem. For this one is the equilibrium of a rope. Okay, equilibrium of a rope. So the equilibrium happening at a point. Okay, and I believe some of the problem there I have already put it in our previous homework. So for your homework, I will put this as part of your homework later. What else? This one as well is a trust problem, but here there is a mistake in the problem, because if we use some other way, the result is slightly different. So I will not put it in the problem because the dimension here is slightly off. Okay. I believe for this one, most of you will be able to solve this problem. It's a trust problem, and you can see whenever you try to solve the problem, try to take a look at the problem carefully. You can see here, okay, that it is stated there that the forces happening at A and B are 1.6 kilonewton each, which means at A there will be a downward force 1.6 kilonewton, and at B there will be another downward force 1.6 kilonewton. Okay, the one that is in question is the axial force in the member CF, DF, and FG. Okay, CF, DF, and FG. Okay, I believe for this one you will be able to solve it. Let's check for the other problem example from the previous exam. So this is from 2017. Hey, wait. If that one is 2017, this one is what? Huh? This one is 2017. And this one is, so this one is for this short, this one is for special semester, I believe. Yeah, it's special semesters. Because it's slightly off the time. Okay, you can see some of this, I already put it in your homework. Number 1 here, I already put it in your previous homework. Number 2 as well, I already give it there. This one, number 3, I will give it in your next homework. Okay. And this one is from 2019. Some of this I already put it in your homework as well. And this one just now we already discussed for this. Okay. And then this is from last year. Okay. I believe this is the one that I will discuss until the end of the class today. Okay, so this is a trust problem. And we have this as well. This is equilibrium problem. I believe I put it there in your homework. Yeah, this one is the how to move the force. So most likely in our exam, most of the time we will have a 2 to 3 question. So equilibrium problem will be there, of course. Trust problem will be there. But sometimes, and most of the times, there will be a problem about the resultant, the force and moment resultant, and how to move the force and how to create how to just representing all the forces and moment with just one force or one force and one moment like that. Okay, that's normally what will be there in your exam. Okay, about this exam preparation, anyone who want to ask question before I start discussing about this particular problem? Anyone? No one want to ask question? Aurelia, do you have any question, Aurelia?
Actually, what was axial forces?
Axial forces is actually, yeah, we haven't explained it yet about that one yet. Right? This one, okay. Where was it just now? This one? Oh no, this one. Okay, which one? Oh, this one. Okay, axial force here, right? Actually, the axial force there is actually, it means that the force which is happening at the member. So basically, when we have a member like this, okay, the force is there. If we talking about thrust, okay, Aurelia, the force is there is either tension or compression. Okay, axial force is actually the force which is in the same direction as the member direction. So the forces that we are talking up until now in the thrust problem is always axial force. You get it, Aurelia?
So it's just force that's acting on the member.
Yeah, correct.
Okay,
in the
thank you.
thrust member, it's always axial force. Later, at the end of this semester, you will learn about other type of force, which is not axial, which is not in the same direction of the member like that. And there are several type of forces. We name the forces based on the direction in comparison to the direction of the member like that. Okay. So when it's stated axial force, it means that it's the same force that we learned up until now. So the force which is happening at the member in the thrust. Okay. So later I will put it as the homework, and let's discuss about this problem. Okay, because it's quite, yeah, it's quite challenging because it has a pulley over there. Okay, I already put it in here. Actually, I plan to make it as your homework, but I changed my mind. I believe it is better for us to just use this as to this and discuss it today. Okay, first let's see together about this particular problem and then solve it together. So it's as stated here, it's a truss structure loaded with F1, F2, and W. Yeah, there is F1, F2, and W. The magnitude of F1 is 100 Newton, F2 is 200 Newton, and W is 550 Newton. By inspection, which bar is zero force member. So we have to analyze the zero force member by inspection first, and then calculate the force on the rod EF, BC, and HG. So the first one is to find the zero force member. The second one is to find out these three and determine whether it's under tension or compression with the value as well. EF, so this one, BC, this one, and HG. Where is HG? Or HG, this one. Okay. So that's the thing. F1 is 100 Newton, F2 is 200 Newton, W is 150 Newton. Wait a minute. I will ask one of you to help me. Alberto Hans.
Yes, sir.
Alberto, are you an international student or regular student?
International.
Okay, international. Okay, Alberto, for your case, I need your help to do the first question to determine which one is the zero force member without calculating, just by inspection. Remember, we have two two rules for zero force member, right?
Yeah.
Can you find it out at the zero force member? Okay, before that, then seems like you forgot about the rules, right?
Is it gonna be DE?
BD?
DE.
DE? Okay, yep. Okay. DE, okay, yeah. And so this one will be zero force member. What else?
And the other one, the
What is connected to DE there at the corner?
AD.
AD, yes, correct. So if DE is zero force member, AD will be zero force member, right?
Sir, can
Because
I ask? In AD, isn't there AY?
huh? Okay. As I told you, right, Alberto, when we already determine that a certain member is zero force member from one particular joint, like this, in this case is D, joint D, we already determined that AD and DE will be zero force member because it is impossible for both to have a force when we analyze joint D, right? If that's already been done, we don't have to see what is happening to the other joint. You get it?
Okay.
So the determination of zero force member can be done only one side of the joint. Once it's zero force member, it will be zero force member, regardless of what is happening to the other joint. You get it, Alberto? By looking at A, yes, we don't know yet about whether AD is zero force member or not. But by looking at D, it's clear that AD and DE is zero force member. The same for DE. When we take a look at the joint E, okay, we don't know yet whether DE is zero force member or not. But by taking a look at a joint D, okay, it's clear that DE is zero force member. Do you get it, Alberto?
Yes.
So our zero force member here will be DE and AD. Okay, is there any other zero force member there? Alberto, is there any? If there is no more, it's supposed to be okay as well. What do you think? Any other zero force member or just these two?
Maybe just that.
Yes, right. It's only these two. We only have two zero force member. Okay. This is by using the first rule of the zero force member. Okay. And because of that, because these two are zero force member, then we can try to simplify the problem. Okay. We can try to simplify the problem. So we can just delete both member, DE and AD. So we can just delete both. So this one we can just scrap it. Okay. We don't have this anymore. Okay. Now this will become the simplified problem. This is our simplified problem. Okay. DE and AD is no more. No more. Okay. The next one is Alberto, still Alberto. We are asked to find out the force EF, BC, and HG. What should we do there?
EF.
Okay, but first, before that, would you want to tell me whether this particular problem is actually a statically indeterminate problem or statically determinate problem? Please try to take a look at the joint. Please try to take a look at the constraint there. What do you think, Alberto?
Indeterminate.
Indeterminate, yes, correct. Because at A, it's a pin joint. Okay, at A, it's a pin joint, and at H, it's a pin joint as well. Because at A is pin joint, it means that there will be two external force there, AX and AY, and at H, there will be two external force there as well, HX and HY. Okay, and but the member, remember, okay, the member CG and GH is two separate member. So if you take a look at GH, okay, can we just replace it with one external force, Alberto, in order to make this problem determinate problem, statically determinate? Hello, Alberto?
I guess so.
Yeah, remember what we have done before in this case, okay? Just now we discussed about this problem, right?
Yeah.
Okay. Actually, what we are trying to do is the same as what we do at ED.
E. Yeah.
Yeah, ED. So at E, there will be EX, EY. If we don't simplify ED as external force. So in order to simplify the problem, we try to make the ED, we try to delete ED and replace it with external force. And it will become like this, right? It will become like, okay, yeah, like this, right? Just now. Yeah. So that's the thing that we are trying to do right now.
Okay.
Okay.
So
So we can simplify GH, right?
yeah, so just FGH.
FGH, correct. Okay. And as usual, we will not be able to solve this without solving the external force first, because right, this one is kind of problem that normally we will do a section method here, right, instead of just doing a join method one by one. Okay, so in order to solve for this, it is better for us to just solve for the external forces first. Okay, remember we have several external forces. We have FGH here, we have AXAY here, and we have the external forces due to the pulley as well, because it's not yet solved, right?
Yeah.
Which one that you want to solve first?
Maybe at A.
Are you sure? Okay, the pulley here, we don't know the radius, right?
Yeah.
If we don't know the radius, what is the one that I told you before? We're supposed to do what here? We're supposed to transfer the force to the joint G, right?
Okay.
Okay, we're supposed to replace the pulley and transfer the force which is happening at the pulley to join G. Correct, right? Yeah. So this is actually the first one that we have to solve.
Oh, okay.
So when you have a pulley, okay, this is for everyone. When you have a pulley, okay, try to take a look at the problem. Do we have the information on the radius or not? If no, then in that case, it is better for us to solve for that one first and replace the pulley with and after that try to remove the pulley and move the force to the joint. You get it? Okay, Alberto.
Yes.
Okay, so let's try to take a look at the pulley G. Okay, what force is happening there?
The weight.
The weight. Where we supposed to put the force?
Downwards.
Downwards here, right?
Yes.
What is the weight? 150 Newton.
Yeah, 150 newtons.
Okay, what else do we have?
And then FFG.
FFG. Wait a minute. No, we don't have to put the. FFG. Yeah, we don't know. We don't have to put all the member there. So we just
FGH.
You just put it as GY and GX, which represent the force which is happening at the pulley due to the joint G. You get it? Later,
Yes.
that force is the one that we will transfer to joint G. Okay. What else do we have there?
Maybe FGH.
GH. No, GH as well. No.
I mean the cable to the right
cable.
tension.
Yes, and this one is correct. Okay, FGH is happening to the joint as well. So we don't care about that yet.
Okay.
So tension here. Okay. Can we solve for the tension force?
Yes.
Using what equation?
Sigma Fx.
Sigma Fx, we don't know the Gx value yet. So the one that we already know the value is only the weight 150 Newton downwards.
Yeah.
So we're supposed to use what?
Moment.
Correct. Sigma moment at G equal to 0. By doing so, what we will have is 150 Newton multiplied by a radius, right?
Yeah.
Minus T
times
multiplied by a radius equal to 0. So T is equal to 150. Yeah. Okay. Then we can solve for Gx and Gy, right?
Yes.
Okay. Gy, we can solve it using sigma Fy equal to 0. Later, what we have for Gy is Gy will be equal to 150 Newton, right?
Yes.
Okay, so 150 Newton minus Gy equal to 0. So this is the end results. And then using sigma Fx equal to 0, what we will get later is T minus Gx equal to 0, right? T is 150 Newton, so we will get the value of Gx. Gx is 150 Newton.
Also Gy 150.
Sorry?
Gy also 150. Oh yeah.
Yep. Yeah, you get it, right? Sigma
Yes.
Fy equal to 0. What we will have there is Gy minus 150 Newton equal to 0. So Gy is equal to 150 Newton, right?
Yeah.
Okay. And then sigma Fx equal to 0. What we will have there is T minus Gx is equal to 0, right? And T is 150 Newton. So 150 Newton minus Gx is equal to 0. So Gx is equal to 150 Newton, correct, right?
Yes.
So we have Gx and Gy value. And now we try to simplify the problem then. Okay, this one is already there. Okay, now we will try to simplify the problem. Now the problem will become like this. This is our simplified problem. Okay, and then we have AY, AX, F1. What is the value of F1 just now?
100
F1
Newton.
is 100 Newton. So we have 100 Newton here. We have
200.
200 Newton here. And at G, there will be GX and GY, right?
Yes.
Okay, GX, GY
150.
is left up. Okay, both 150 going to the left and
Yeah.
up. So here, where we supposed to put the direction of the GX and GY? If in this case it's left and up, in this case, it's actual reaction.
To the right.
Okay, so right and
Down.
down. Okay, so it's GX equal to high 50 Newton. And this one is GY equal to high 50 Newton. What else do we have here? How about GH?
Oh,
Have
yeah.
we
Yes.
included? Not yet, right? So we have to include GH as well.
Yeah, include GH.
So FGH. So that's it, right? This is all the external forces which is happening to this particular simplified problem. So now our region of interest is just that one. Okay.
Okay.
Can we solve for AX, AY, GH? Of course, right? We have three equations, right?
Yes.
Sigma Fx equal to 0, sigma Fy equal to 0.
Oh yeah, and then we have
Sigma
two
moment.
unknowns on.
Yeah. Okay. So we can solve for that one. Okay. The first one that we want to solve is GH because GH is us, right?
Yeah.
So then in order to solve for FGH, which one that we're supposed to use from these three?
Sigma Fy.
Are you sure sigma Fy? AY is still there.
All right. So we can use.
Try to eliminate AX and AY. How can
Moment.
we eliminate AX and AY?
Moment.
In order to solve for FGH,
Can maybe just use the moment. Sigma
moment at
A.
At A, correct. That's the way to solve remove AX and AY in the equation, right? So
Yes.
sigma moment at A equal to 0. Okay, by doing so, we will be able to find for FGH. Okay. So what we have there for sigma moment at A equal to 0?
100 times 2.
Yeah, 100 Newton times 2 meter. What else?
200 Newton times 4
So
meter.
this one is clockwise.
Yeah, clockwise positive.
200 Newton times 4 meter. What else?
GY?
Yeah, 150, right? Because we know the value. 150 Newton multiplied by 6 meter. Okay, what else?
And
GX, how about GX?
oh yeah, and GX.
Yeah, GX plus 150 Newton multiplied by what?
6 also.
You sure 6? This one is the rotation is like this, right? This one is the rotation is like this as well. The moment arm is what for GX? 2 point. Huh?
Sorry, I got.
The moment arm of GX here to point A is what? You cannot just simplify more. You cannot just multiply by 6 because 6 is the moment arm of GY. Yes, correct. But the moment arm of GX, remember, right?
It's
This one, right? This is
2 meter, 2 meter, 2 meter.
2 meter.
Sorry. Yeah.
2 meter. Okay, what else? How about FGH?
Yes, FGH, but you don't know the value.
Yeah, we don't know the value,
yeah,
but
so
it's
that's the
okay
variable.
because
So,
we want to find the value of FGH. Okay, so the angle there is 45 degrees. So FGH there, you can just divide it by 2, right?
why?
FGH cos 45 and FGH sin 45.
Oh yeah.
Because it simplifies, because the moment arm will be much simpler, right? Okay, FGH cos 45 degrees. So this one is the angle. Okay, what is the moment arm for the FGH cos 45 degrees, the horizontal FGH?
2
The
meter
same,
also.
yeah, the same as the GX, right? 2 meter. And then we have FGH sin 45. But that one will give a counterclockwise direction. So it's supposed to be negative. FGH sin 45 degrees. And what is the moment arm there? 6 meter, correct? Because it will be the same as GY, right?
Yep.
And everything will be equal to G. Okay. Would you mind to calculate this for me?
Okay, give me a moment, sir.
I will try to calculate it as well. $200, 800. This one is 200 Newton meter. 800. 800 Newton meter plus 900 Newton meter plus 300 Newton meter. Cos 45.
I got 777.93.
Okay, 777. Let me check. Okay, 2200. And it's supposed to be minus, right? Sorry, plus, right? Plus, right? 2200 minus. So 2200 is equal to
2.828 FGH.
yeah, 4, 2. Yeah, 2.828 FGH. So FGH equal to
777.93.
yeah, correct. 777.93 Newton. Yeah. So you solve the first problem, right? FGH.
Yeah.
So you solve this one. FGH is solved already. Now, after you know the FGH, do you need to this one? Then calculate force on the rod, okay, and determine the type of the rod, whether it's tension. Okay. AX and AY, do we have to solve it or not? The one that is in question is the next one that we have to solve is EF and BC. So this one, EF and BC. Sorry, BC is horizontal, the one bottom. Okay. In order to solve for this what we're supposed to do, Alberto? We have to cut, right?
Mhm.
And how to cut it?
Just through the middle.
Like this, right?
Yes.
And after you cut it, you can analyze the left one. Okay, you can analyze the left one, or you can analyze the right one, right?
Yeah.
And for the
Also, we
right
don't
one,
need. We don't need.
yes,
this.
correct. With FGH
this
is already solved,
Yeah.
so we do not need to solve for AX and AY if we choose for this one, right?
Yes. Correct.
Okay, so the next one that we're supposed to do is to cut it, and after we cut it, sorry, this one. Okay. Now we have 10 more minutes. Okay. Okay, we can just cut it here. So what we have is just left with this triangle, right?
Yeah.
Okay, so we have FCG there. So this will be our last free body diagram. Okay, and what forces that we have there? This one is C, this one is F, this one is G. What forces that we have there? Actually, we just can see all these external forces will be there, right? And left with the E and with the three remaining member that we cut just now. Okay, so 200 Newton will be there, GXGY will be there, FGH will be there as well. 200 Newton, GXGY. This one is 150 Newton, 150 Newton, and FGH. What is that? 777. 777.93 Newton. Okay, and then we left with the remaining member that we got. So there we have EF, BF, and CB, right? ABC, right? So assume everything is under tension. Yeah, so this one is FEF. This one is FBF. And the last one is FBC. Okay. The one that we have to solve is what and what?
It is asked for FBC and FEF.
Okay. In that case, what equation that we're supposed to use? Okay. This is the most important thing to you guys. Okay. You just need to solve what is us. You don't have to solve what is not us. Okay. So what equation that we're supposed to use in order to solve for this?
Moment and FX.
Moment, yeah, moment and FX. Yes, correct. Which one that we're supposed to use first? Alberto?
You could use FX first.
No, if you use FX, it will be BC, EF, and FBF together.
Oh,
right?
yeah, right. So moment first.
Yeah, moment. Actually, wait a minute. The one. Yep. We have to use this one. Is like it or not? We have to use all of these three because FBF has a X component as well. So, but in order to make it easier for us to solve this, we need to use the sigma moment first. Sigma moment at F equal to 0, because by doing so, we will be able to solve for FBC, correct, right?
Yes.
Okay. if we want to do this sigma moment at f equal to 0, then what we have there, Alberto?
Sigma moment F. We have, oh, there's a lot. We have FGH 777.
Yeah, 777, but that one is better for us to divide it by 2. There are a lot, yes, correct. So we have a 777.93
Cos and sin.
cos 45 degrees multiply sin, okay, sin 45 degrees multiplied by what? 2 meters, right?
Yes, 2 meters.
2 meters. What else that we have? The cos one, there
Yeah.
will be no component, no moment component on the cos
So
one.
0, so we don't need to write it.
150 degrees horizontal, there will be no component of moment there. 150 degrees vertical, there will be.
No.
So,
Oh, yeah, 2 meter.
yeah, so this one will be minus 50 Newton. This one,
Yeah.
multiply by 2 meter. Okay, because counterclockwise is positive. What else? 200 meter here, it will be
0.
no moment component as well.
FB.
So we left with FBC, right?
Mhm.
FBC, it will be minus or plus?
Minus. Plus because clockwise.
Okay.
Oh.
But remember, I already determined
Oh,
counterclockwise positive. So minus
Okay.
FBC multiplied by 2 meters equal to 0. Would you mind to calculate it for me? What is the value of FBC?
That's sin 45, right, sir?
Yeah, sin 45.
It's 800.16.
800
I have
point.
divided by 2.
Oh, so 400 then.
Yeah. 400.08.
Okay, just 400 Newton. It means if it's positive, it means that it's tension. Okay. Don't forget to put the tension and compression there. The same FGH just now, we find out the value of FGH and it's positive. So it means that it's tension as well. Don't forget to put it there. Okay, because we are asked to inform this. Then in order to solve for FEF, we have to solve using sigma fx and sigma fy equal to 0 because F has a x component there. So like it or not, we have to solve for FPF as well in order to solve for FEF. Okay. So you use this sigma fx equal to 0, sigma fy equal to 0, these two equations to solve for FEF like that. Okay. You can do this by yourself because it's just a simple case. Okay, but this is how we handle this particular problem. So the one that you have to remember, guys, okay, when we have a first problem, try to analyze the zero force member first. Is there any zero force member? If yes, simplify the problem. Then take a look at the problem. Is there any pulley or not? If there is a pulley and the radius is not yet known, then you have to move the force which is happening at the pulley to the joint. Like just now, we move everything to joint G. Okay, we move everything that is happening to the pulley to joint G. Okay, GX, GY here. Okay, and beside that, if you have one particular member dangling like this, okay, instead of solving for the joint H like this, instead of solving for the joint H, it's better for you to just remove the member and replace it with a force representing that member, FGH like that. Because by doing so, you will reduce the number of unknowns there. So here, we remove this and replace it with FGH. That's all the things that you're supposed to know about this particular problem. How to simplify the problem. Okay. I think that's all. Okay. Remember to prepare yourself for the exam. Okay. The exam will be. We will give the exam next week. Okay. And the topic that will be covered in the exam is from the beginning until the end. Thrust. Okay. Until thrust. So force, moment, resultant will be there, equilibrium will be there, and thrust will be there as well. Okay. I think that's all. Anyone want to ask question before I wrap up the class? Apakah ada pertanyaan? Silakan. Kalau tidak ada, mungkin itu saja. Pengumuman terkait dengan ujian akan saya berikan di EduNext. Okay? The announcement about the exam, I will put it in the EduNext. I think that's all for today. Thank you very much for coming and listening. See you guys next week. Okay, bye.
Thank you, sir.
Thank you, sir.
Thank you, sir.